right, so it says the I can statement, I can use the ambiguous case of the law of signs to solve problems. The ambiguous case of the law of signs. So here is what we have. We have the ambiguous case of the law of signs given. Triangle ABC, the measure of angle A, C, and A. The triangle can have 0, 1, or 2 solutions. Okay? Let's go down a little bit there. All right, so if that is the case, let's take a look at this. We are not going to explore using the GeoGebra because it's not really all that great. Given triangle ABC below, draw the two different triangles that can occur when given two sides of a triangle, C and A, and the non-included angle of A. So in this case, if we take a look here, we have a couple of things going on. First off, when we draw this line down, this ends up being an isosceles triangle. So that means we're going to have that A1 is equal to A2. But because of that, that also means that the measure of angle AC2B is supplementary to the measure of angle BC1A. We also have the height of this triangle right here. We're going to call it H. That's just by dropping an altitude. And we have two solutions when A1 is greater than H. All right, so everybody have this written down. Okay. If we took at the next part, so we already drew that altitude, it says when does the triangle of ABC have no solution? And that's when A1 is less than H. And then when does it have one solution? When A1 is equal to H. Now, here's the thing about the law of signs. Yes, we're doing this in terms of H, but this is kind of why it exists. You don't necessarily need it to solve, though. Okay? And that's probably going to save you some time. But I know on one of the ed puzzles, it does go through how to in case you choose to. Okay? But you don't have to. Anybody still writing that down? Okay. So, how do you know when you have the ambiguous case? Well, when given two sides and one angle across from a given side. So what is that? We understand that we use law of cosines as, what is it, side, 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 and side angle side, right? Law of sines had their own that we kind of viewing that we used for triangle congruency. What's this one? Can anybody visualize it? Was it? No. It was the no-no one to prove triangle congruence. Which one was the no-no? Side angle. Yep. So this is side angle. Anybody still writing? Okay. Let's move on. Now, this is where it's going to get real. Take out those calculators. Your first step for every problem is to ensure that you actually are in side angle in some point. Okay? And your best bet is to always have the parts that you have two of to be like this, like across from each other. Okay? I'll show you that in the next problem. But this one says, find all possible solutions for triangle ABC and round all measures to the nearest tenth. If we take a look, we have this and we have A. So the next only thing we can really solve for is angle A. So I'm going to find angle A by saying I'm going to take the sine of 73 over 5 equals the sine of A over 7. Now, what do we usually use here to find angles? Well, you're definitely going to cross multiply, yes. But what do we use to find angles? The inverse, yes. That -1. So someone tell me, I want you guys to solve for this. The measure of angle C is about equal to what? And it does say to the nearest tenth. Find the measure. I'm sorry, angle A. Sorry, I looked at the wrong one. Thank you. Angle A. You're going to get something funky. It's okay. Umar, got it? You got an error? How could that be? Who else got an error? Error? Anybody else? Error?
I'm still confused.
Yeah, guess what? There's an error here, which means probably what?
No solution.
No solution.
I got an error.
Yeah, but be careful. Make sure you double check it to make sure you typed it in correctly because there's no like help with that one. Does that make sense? All right. Number 2. Excuse me. Says find all possible solutions for triangle DEF. Round all measures to the nearest tenth. So I am going to redraw this triangle. Why? Because it's going to make life a lot easier if I do. And how I set this up is usually like this. I draw just to make it bigger. What they give you is kind of crap. All right, here's F. I'm going to relabel this F, and I'm going to have here my 63 degrees and my 9 over here. The angle I'm trying to find is E, so I'm going to put that over here. And here I'm going to have 12, and then this will be D. DEF. It's still all, I just redid it to make it easier on myself. You can move these out. Remember, it doesn't matter how you draw them as long as all the information is correct, right? Across from E is, oh, wait, I see. Yeah, I made a mistake. No, you're right. I did. Sorry. My fault. There we go. This should be 12. This should be 9. There we go. Sorry. I didn't even look at my own notes for that one. Does that make more sense now? Sorry. Okay, so There's only one thing we can calculate here, and what's it going to be? E. Okay, so we're going to find the measure of angle E. Okay. Just bear with me. We're not done yet. This is going to be the inverse sine of, well, I guess it would help if I actually set up the ratio, huh? So this will be the sine of 63 over 12 equals the sine of E over 9. So what is the measure of angle E? And this time I'm telling you, it is not no solution. What do we get?
41.9.
41.9. Very good. Okay. Now, the next step is going to be to solve for the measure of angle D. How do we do that? That's going to be 180 minus 63 minus the 41.9. Yep. Okay. All right, listen up. This is where things start to get weird. And this is why I didn't really want to redraw them, but it's kind of necessary to solve the problem. I promise you'll have more space for number 3 and 4. More than you even know what to do with. Okay. Shh. Now, the ambiguous case means that we can potentially have more than one triangle here. Yes. And that's how we're going to apply what's in the front. So what happens is when you apply this, you are essentially dropping something here to create that second triangle, and it creates this isosceles situation. Okay? And when it does, that means this side is 12, and these two angles are equal. Now, what you need to confirm is if this triangle actually exists. And so if I redrew that down here, now for angle E, this is our supplementary situation. We're going to take 180 minus the 41.9. This gives us about what? We got
138.
that leaves us with 138.1. Now, we need to confirm D. This is done using this angle and subtracting from 180 to see what we get here. So this is going to be 180 minus 138.1 minus 63. What does that give us?
-21. So is it not true?
So what this means is
Triangle.
we have one solution, which is just one triangle. And that's your original. So the only thing left you have to do for one solution is find that third side.
Am I rounding to the first or second decimal?
First is fine. So we're going to find right here, this triangle, doesn't exist. This triangle does though, and we know the measure of angle D is 75.1. So we're going to use again the sine of 63 over 12 equals the sine of 75.1 over little d.
I'm a little confused. How is this triangle not existing?
It means that it's not connected. Like that means that they gave you three sides, but those sides are not necessarily connected.
Didn't we already get angle D?
Wait, why is there a little?
Got angle D, you're solving for side D now.
So is that FE?
Yeah,
Okay. Can I do the cosine though?
you cannot do the cosine.
Why? If I already have the angle of D and I have the two sides. I got 13.
You got 13?
Yeah.
Why didn't I write this one down? I write this one down. Oh, it is 13. Good job. So yeah, I guess it would work. I didn't think about that. Okay. So, yeah. So we have no solution, which means we don't even have a triangle here. One solution means that we're just doing the original law of sines. Now we're going to investigate two solutions. Yeah. It doesn't connect. The side, like if you physically had all the sides, they wouldn't connect. That's what it means. But since you don't have all the sides, you got to like find those angles, and that means if the angles don't exist, then the triangle doesn't exist. Does that make sense? Yeah.
Is this gonna be on the test?
Absolutely.
What do you mean?
All right. Let's take a look at two solutions. All right. Find all possible solutions for GHI, round all measures to the nearest tenth. So, again, I'm going to rewrite this triangle. So I'm redrawing it, again, to make my life easier. So here's I. So here's 45 degrees. This is 27. Now the other angle I'm trying to find is H. I'm going to put that over here. And the opposite side is 28. And then what's left up here will still be G.
So we find the letter H.
So we find the measure of angle H. Go for it. So what's the measure of angle H? 47.2. Very good. Okay. While we're at it, let's find the measure of angle G. Because if there's one solution here, guys, that means I have everything I need to solve for this little G on the other side. Okay? What'd you get? 87.8. Very good. Okay. So we have everything we need for the main triangle. Now, we need to talk about the two triangles. Five. No, it's G. It's a little G. Sorry. No fives. Let's try that again. This baby G. There we go. Is that better?
Yes.
Okay. Maybe. Okay, so again, I'm going to just kind of rewrite this. I know here I have 47.2. And I'm not worried about the top part just yet. Now, I am going to create my isosceles triangle situation. I'm going to drop this. This becomes congruent. That becomes congruent. Which means if I am drawing another triangle here, I have G, and I have my brand new H that just kind of moved over. Now my brand new H is going to be supplementary to this 47.2 because these two angles are congruent. So I'm going to take 180 minus 47.2. What does that leave me with? 132.8. I still have here my 45 degrees. And now I need to solve for this G. And I do that by taking 180 minus 45 minus 132.8. What do I get for that? 2.2. I have another triangle here that exists. Like the last one, remember how we got that negative angle? That means that triangle doesn't exist. We only have the one triangle to deal with. And that's just straight law of sines like we did before. This one, because this triangle exists, we need to find two separate sides. One for the main triangle and one for this other triangle. Okay? So what this means is since I have two solutions, my first solution is solving for everything for this triangle. Now we have the angles, which is not problematic at all. And so I'm just going to kind of write in that information. And I got to solve for this little g. So to solve for little g, I need the sine of 45 over 27 equals the sine of 87.8 over little g. And someone tell me, what is little g for that first solution? I think so. Yeah, I got 38.2, but yeah. You're supposed to have all the sides.
I got annoyed for a second because I forgot you had flipped it and I had it.
And that's what happened this morning when I was looking at these. I'm like, why didn't they flip these around? And I didn't have the picture, so people got really frustrated. So during my lunch, I redid it all. It's not that the information was incorrect. It's just there was no visual component with it. So I'm like,
Why do we have to flip it?
honestly, it's just more visually appeasing. It makes things a lot easier. It really does. Otherwise, you're going to be getting the first off, they don't give you enough space to even put like this. Do you know what I mean?
On the test, can we like 38 blank piece of paper?
You can write all over the test. There's going to be a blank piece of paper on the back. Okay, now that takes care of solution one. The second solution is with this triangle. Now we have this isosceles situation going on where this is now 27. This is 28. We have 2.2. We got to find, this is our little g. So for the second solution, we're going to have the sine, again, of 45 over 27. That comes from here. 45, 27. Like that didn't change because this isosceles is still 45 over 27. Equals the sine of 2.2 over little g. So what is the second solution for little g there? Hmm?
Is it 1.5?
Yep.
I like doing it with the cosine instead. I like doing it with the cosine instead.
Fine. How we doing? Questions? Help a girl out. What we got? 1.5 is the answer. All right. Here's my question. Do we want to try one? Or do you want me to do it with you? You want to try? Who says, I want to give it a shot on my own? All right, go for it. And then we'll go over it in a few minutes.
Right as I say that, my brain starts working.
It's all right. 4 is very similar to 3. Oh, FYI, guys, I just heard from the other geometry honors teacher. She is, what does it say? Tomorrow there's after school tutoring. If you want more help on the ambiguous case, the other honors teacher is going to be there. Room 109. I'll put the information in Google Classroom if you want to go. Definitely couldn't hurt, right? Huh? It's right after school.
I can't do it if I want to. We're only got 30. Oh no. I'm working really slow, but better slow and get it right than fast.
Agreed. This one you do need to take slow.
Wait, how do I know which side to make a triangle? Like to make a second triangle?
Okay, so remember you're always taking like that side A,
Okay.
like one over here, and making it isosceles. But you gotta like fix the triangle so it can do that easily. Do you see what I mean?
Yeah. I'm gonna draw a figure. No, I want to
Not angle. Yeah, but we need to do they must have drone. We didn't. I'm just kidding. I don't feel it bad. I redraw. I said Montana. Montana. I asked you some no answers. Not a try. Yeah. Oh my god. What's the third? What's JL? What's JL? Wait, how do you find the sign?
Show of hands. Who's still working on it? Okay, just checking.
I'm getting this. This is good.
The second triangle part.
This.
So think of it this way: you're gonna subtract 180 from the one that the angle you solve for, and that's what gives you that other angle, right? And then you still have the original that you were given, and then you just using those two pieces of information, you find that third and see if it exists, and then if it does, you just use the law of sines to find that side. You're not solving for J.
What are we solving?
K.
Okay.
Because you have nothing for K. So it's J29.
But K is equivalent to 18 because of that.
K doesn't have an angle because it doesn't have a side. You were calculating for L.
I solved for this side.
That's not the right side though.
Oh wait, I think I.
Do you see what I mean?
I think I had an aneurysm.
That's okay. That's why we talk.
Oh yeah. Okay.
So you got the other side K. Yeah, that one's good. And now you just need the other one.
Yeah. And I was trying to. So is that like writing it out? Or?
Well, I mean,
I feel like there might be something wrong with the sides.
I'm trying to think. Hold on. The side. You gotta remember that when we do that isosceles triangle thing, the sides isn't being congruent. So if you have here L K18, J is 17, right?
J is 17. Yeah.
Yeah, it gave you J. So if you have J,
I should only have J and 18.
yeah. So now what you need to do is, since you calculated for L and you got 30.9, right?
Yeah.
You're looking for the supplementary part to that
Okay. So
because you just have your triangle flip flopped around, huh?
So subtract 180.
Yeah, and then you'll have that second angle. You keep the original angle, and then you subtract 180 that to get that smaller angle.
Okay, so wait. It shares this in this triangle. Oh wait, no. In this triangle, it shares the side is the same as this, so it would still be 30.3, even if you separated it, because K is here, right, and it gets 30.3. But when you do that and make it a separate triangle, it's still 30.3.
Yeah, I'm not ignoring that, the problem is that you have the wrong isosceles part.
Huh?
Here.
Is this the isosceles?
Okay. The isosceles part that I got was 17. Because I set it up as J29, 17, and this is the angle I calculated. So this is the angle that's going to repeat over here. So angle L is supposed to repeat. You have it as angle J repeating or something like that. K repeating. That's not the case.
How are we supposed to know?
Well, first off, K is totally blank. So K could be K is the only option that can be two angles. K doesn't have a side, K doesn't have an angle measure. That's why we don't know. That's why we're always basing it off of what is not there. Does that make sense? All right, ladies and gentlemen, because we only have a few minutes left, I'm going to give you the answers. Okay? 7. No. The measure of angle L should be about 30.9. The measure of angle K, the first measure of angle K, should be 120.1. This is all for first solution. That means that little k for this one is going to equal about 30.3. Now this has a second solution. Again, you still have angle L as the same. However, angle K is going to be 1.9. And this makes little k, the second solution, about 1.2. Now, I'll be happy to go with you over this with you a little bit more tomorrow. I'm not giving you a worksheet tonight. I'm going to give you a worksheet tomorrow for homework. So I think we need another day on this. But you do have the 2 ed puzzles. Remember, even though it's extra credit, it's required. Get it done. This one has 2 solutions, yes. Yes, it's required. Don't do it. I will scream. And it'll be marked as NHI, not 0. Have a great day, everybody.